Hi everybody, today we're going to look at a second way to write vectors, which is called the component form. When we talk about vectors, they have both a horizontal and a vertical piece, which we're going to call a component. To work with each piece independently, we use two special vectors. We use the vector I, which is equal to 1, 0, and the vector j, which is equal to 0, 1. That means we can take any vector u and think of its first component as a scalar that we multiply by I. Then we take the second component, think about it as a scalar, and multiply it by j. Let's take a look at a few examples. We'll start with the vector 5, 3 in standard form. To write this in ij notation, we say 5 times I plus 3 times j. Looking at the vector w, that's written in standard form as negative 6, 9, we would write negative 6i plus 9j. Mostly what I want you to see is this is just a matter of notation. We didn't do any calculation to convert from standard form into this component form. We can use the idea of vector components when we are given the magnitude and direction of a vector and we don't have the individual components. If I look at a vector u and only take into consideration the magnitude, then I would see that it's composed of an x value and a y value. To get the values, I need to incorporate the angle theta. We know that cosine of theta would be equal to x over the magnitude u. We could rewrite this and solve for x, which gives us x is the magnitude of u times the cosine of theta. We can also look at sine theta, which is equal to y over the magnitude of u. Rearranging this equation, we get that y is the magnitude of u times the sine of theta. This allows us to write the vector u as the magnitude of u times the cosine of theta I plus the magnitude of u times the sine theta j. Let's write the vector v in the form ai plus bj given its magnitude v and the angle alpha it makes with the positive x-axis. We're given that the magnitude is 20 and the alpha is 30 degrees. We'll start by bringing in our formula. V will be the magnitude of v times the cosine of theta I plus the magnitude of v times the sine theta j. I'll put in 20 for the magnitude, I'll put in 30 for the angle. Now we have v is 20 cosine 30i plus 20 sine 30j. Luckily, 30 is a value we should know from using our unit circle. We have that v is 20 times the square root of 3 over 2i plus 20 times a half j. If we leave this in exact form, we have 10 times the square root of 3i plus 10j. Let's look at another example. This time we have the magnitude of v is 15 and our angle is 218. Again, we bring in our formula. V is the magnitude of v, cosine of theta I, plus the magnitude of v, sine theta j. The only difference we have here is that I have alpha instead of theta. Using our values, we have v is 15 cosine of 218i plus 15 sine 218j. 218 is not a value we have from our unit circle, which means we need to grab our calculators. As always, the first step you should do when you grab your calculator is check your mode and make sure it's put in degrees. Rounding to 3 decimal places, I have v is 15 times negative 0.788i plus 15 negative 0.616j. We have negative values because 218 is in the third quadrant where both sine and cosine are negative. We could do one more step of simplification. When I multiply 15 times negative 0.788, I get negative 11.82. When I multiply 15 times negative 0.616, I get negative 9.24. So my vector v is negative 11.82i minus 9.24j.